This is my neighbor Brent. Everybody say hi, Brent.
Hey, Brent.
Thank you. Brent has a fondness for heavy machinery, and over the years he's used some of his heavy machinery to help me move some of my heavy machinery, basically enabling each other's heavy metal hobbies. Now that right there is brotherhood. Anyway, I'm super grateful for his help, but pound for pound, I'm definitely slacking in the neighborly assistance front. Until now. So let's see what I can do. Welcome back to Inheritance Machining. My neighbor Brent has a side hustle making delicious brick oven pizzas out of a trailer, and on that trailer is a dough press. This dough press. It basically takes a ball of dough and makes it more pizza shaped. There's a problem though, and maybe you can spot it. Anybody? Bueller? Bueller? Yeah, this vice grip definitely is an OEM. The problem is, the knob biffed it. This is meant for adjusting the roller spacing so Brent gets the dough to the right thickness for a proper pie. In other words, really important. So we need to fix this, but the first part of any repair project is figuring out what I'm making. Fortunately, I don't have to think too hard. I have a perfectly good example right down here. Looks like it's held on here with a snap ring and a washer backed by a spring. Pretty straightforward. And now I can see what's missing from the broken one. This one seems to be lacking the fancy metal plate on the backside, which would certainly explain this knob's poor state. The metal plate engages with this detent pin to lock the knob in place, but sans plate, it's gotten pretty mangled. I could just make a new metal plate and epoxy it in there, but I don't like that. A man who's willing to wrestle a lathe that isn't even his deserves something better. Whatever plate I might make would likely fall off anyway, and well, this knob kinda sucks. It's hard to grab, hard to pull, and hard to spin. Basically failing at all of its jobs. So let's reinvent the knob. I'm using Onshape for this not only because they're the sponsor, but because I can't imagine switching to any other software at this point. I mean, it just gets so much right that I have no need to go back to anything else. This isn't my first rodeo, folks. The 100% cloud-based structure is what really sells me on it. Because of this, you never need to install, update, or crash a computer that was underpowered to begin with. Onshape works right from your internet browser, which not only means you have the computing power of the whole internet at your fingertips, but more importantly, you can work from anywhere, like the comfort of your office, couch, or anywhere you need to get some real paperwork done. Speaking of paperwork, there is no paperwork. There are also no files. I know this sounds crazy, but once you try it, you'll never go back. Onshape's structure allows you to keep everything related to a project in one document. And further than that, their part studios are for making multiple parts in one location. If you work with cross-referencing parts much, you'll see just how clever this is and wonder why nobody else is doing it. But don't take my word for it. You can try Onshape yourself for free for 6 months when you go to my special link, onshape.pro/inheritance machining. With a slew of prototypes printed up, it's pretty clear which one is the winner. The longest, scallopiest, grippiest, sexiest, juiciest one of the lot. I think I'm getting predictable. Let's get to work. I'm choosing this big old bar of mystery steel I've already got, not because I'm cheap, but because I suspect the lack of rust means it's stainless steel. I don't know a whole lot about food hygiene stuff, but I hear the words pizza and stainless steel quite often. The problem is some stainless steels are hard to machine, and judging by how quickly I just dulled this bandsaw blade, I think this is one of them. I didn't want to jump on the lathe this early, but we don't have a choice now. This carbide parting blade should do the trick, with the support of a fleshy steady rest. Yeah, don't try this at home, kids.
Don't do this at home, kids.
What did I say? Anyway, let's put this shiny carbide to use. I got these for my last batch of aluminum parts because it prevents the metal from building up on the insert. And something tells me this is going to be helpful for this tricky material. Nice. Let's hollow this sucker out for the spring. And judging by the way things are going, I don't think this is stainless. I think it's 316 stainless, which yes is stainless, but it's different, because it's 316 stainless. I don't have a good way to tell other than the consistent horror stories I've heard about machining this material. So I think my key to success here is really drenching this thing in coolant and paying extra close attention to the speeds and feeds. Hey, it's kind of like pizza making. The right ingredients, the right time. Alright, I'll stay in my lane. Anyway, let's shift gears and open this up a whole lot more. Big drilling like this is something I don't give enough credit. I can't really describe how satisfying it is to get the drill pressure just right. Watching these perfect little augers spiraling their way out of the bore is downright hypnotizing at times. Very helical. Much wow. This wouldn't be a proper boring though without the appearance from this guy. Just gotta open this up a bit more and of course flatten out the conical bottom left by the drill. This is by no means necessary, but I think we're well past the point of basic functionality. In fact, I couldn't resist making some other improvements to this dough press. Now it looks like we've either had a bit of a whoopsie or Brent gets really aggressive with his dough, so I took some liberties and ordered a replacement roller guard from Send Cut Send. I don't know if you're aware because I wasn't until this project, but Send Cut Send can also cut and bend plastic. And you don't have to do anything special either. The order process is exactly the same. Easy. So if you've got a project in mind, use the link in my description to get 15% off your order. Speaking of, I just thought of another slight improvement. This knob design is already very grippy, but there's something that could make it grippier. Obviously, I'm talking about knurling. But I've never knurled stainless steel, so I think it warrants a little test before we commit to it. This outer diameter is going to get turned down anyway, so let's try it right now. Okay, it might be kind of subtle to you, but to me, it looks like dookie. The knurling wheels had trouble maintaining consistent pitch, and I can't have that. I mean, you wouldn't serve a pizza that has uneven slices, right? I think I know what's going on here. Theoretically, the starting circumference needs to be evenly divisible by the knurling pitch, and if it isn't, dookie. So I'll let my Texan friend here do a little math, and we can try this again at a better diameter. Yeah, now we're cooking. Talking. I meant talking. I think this is going to work. And this is the one I'm most concerned about. The scallops. If the guy running the shop would stop sending me on side quests, I could finish this radiusing tool and I wouldn't be too worried about this. But right now, the only way I have to make this big honkin' radius is with this big honkin' cutter. I'm just not so sure how well a wide cut like this is going to jive with this stainless. But I'm really out of options, and the people need pizza. Shoot. This is a problem. I'm sure even the non-machinists among you would agree that a sound like that is pessimo. It's chattering so bad even the chips are chattery. This isn't going to work. But before I go redesigning this, I've got another radius I might as well go ahead and test as well. This time of the convex variety. Well, color me genuinely surprised. That's working. Even with the tailstock pulled out of the way, there's absolutely no chatter. So maybe this isn't a complete loss after all. Actually, come to think of it, I might be able to correct this fiddly fillet. It's not going to happen on this lathe though. Because where there's a mill, there's a way. Combination of the rotary table and an end mill of the fillet diameter, and this just might work. Very promising. I'm going to switch to power feed though before I wear out my good arm. I need to save some of my strength for pizza eating. Okay, not only did that work, but it worked beautifully. Just look at that finish. Let's bounce back over to the lathe and complete the turning. Of course, there's nothing stopping us from dropping a tasty knurl on here now. And speaking of tasty, I can't resist putting a chamfer on here as well. Wouldn't want that edge too sharp now, would we? Yep, this was a good decision. Let's part this off and do the rest. The remainder of this work will require the forejaw. Firstly, because the soft aluminum jaws I have on here will protect my precious knurling, and secondly, because it'll allow me to get the knob perfectly re-centered, which isn't so important for facing this to length, but will most certainly be important for everything else. This little flange I left here will make sense later, but for now it gets a little chamfering as well. Now for the bore on this side. This is the one that actually fits over the keyed shaft sticking out of the machines. So I want this diameter to be just right or this thing will wobble all over the place. Trust me, nobody likes a wobbly knob. Then it's back to the mill where the rotary table is lying down on the job. No, don't get up. That's exactly where I want you. We've got to add all the fancy stuff to the bottom, but none of that will be overly helpful unless it's centered. Okay, first is the keyway. Normally these are broached, with something called, you guessed it, a broach. But being Italian, I don't have a metric set of broaches on hand. So the second best option is to mill it. I just have to go a bit deeper to give the radii some clearance from the key corners. That is, if I don't break this itty bitty end mill. There we go. What, did you think I was setting something up there? I never break end mills, especially the little ones. On to the detents. These are basically just a bunch of radially oriented slots. And since I'm using a center cutting end mill, I think I should be good to just plunge this right into the material. Then do my little scooch that turns this hole into a slot. Pretty straightforward, except for one problem. I didn't realize until the fourth one, but that looks like ass. I should have guessed this would happen. The initial plunge is a bit wobbly, so of course the rest of it doesn't get better. I guess I'll do this the right way now and pre-drill first. What do you know? It pays to be careful. These first four are going to bother me a bit, but this is still technically functional, so I'm going to keep on trucking. There it is. Oh wait, there you go. Now you can see my shame. Honestly, not bad to make it this far into a part before breaking something. Luckily I buy these in bulk the way a pizza man buys flour. That takes care of the straight slots, but there's still this curved one. I'll admit, I don't really know what this is for. It doesn't seem like the detent pin even lines up with this, so I'm lost. But I'll go ahead and add it anyway, so I have a good excuse to break more end mills. We made it through, and only 2 casualties. Not bad. But I'm not a fan of how burry this all is. Definitely wouldn't want one of these to break off and make someone's pizza extra spicy. A perfect excuse to use this. Almost brings a tear to my eye. Now we've arrived at the final part of this setup. This mystery flange. What good is a selector knob without a pointer? That's what I thought, so we're going to add one, through subtraction. A perimeter cut removing all but the last 22.4 degrees, and boom, we have ourselves a pointer. Now this knob is ready to go and certainly could be used in this state, but we didn't come here to make a merely acceptable knob. No, we're here to make the best knob. And the best knobs have scallops. Knurling doesn't jive well with the indicator, so I'll get a center on the bore, and then let the end mill do its thing. Now that is a knob worth grabbing. I couldn't let go of this if I tried. I'm just kidding. It's not perfect, so I will let it go. And grab this one. That's right, I made a second. I just couldn't deal with those wobbly slots, and this one is much better, but it's not perfect either. The scallops are a little more flavorful than I would have liked. So I tried again, this time using a plunge technique for those final fillets, and ended up with not one but two more slightly imperfect knobs. One with a lightly crooked scallop, and one with, well, I don't want to talk about it. So yeah, I made 4 imperfect knobs. But plot twist, I planned to make 4 all along. No, not 4 imperfect ones, but 4. One for the replacement, and one so they would match. And then 2 more again because, well, Brent has a whole other dough press with exactly the same problem. What kind of neighbor would I be if I let a man out into the wild with mismatched knobs? One that doesn't get heavy metal help next time, that's for sure. And I want to be better than that. This is the 5th year I've had this shop. It's grown, shifted, and changed in that time. With these videos, I've reached a lot of people, and don't get me wrong, that's cool as heck, but it also feels so good to help someone right in my backyard. Share a bit of the pie, if you will. And Brent, I hope we're a little more even now. As always, thanks for watching, and see you next time.